Section 2.4 is titled the chain rule, and what we're going to do in this section is we're going to take functions that look like they're something inside of something else. Okay? So the basic chain rule definition looks like this. You'll notice the way that it is written on the left-hand side, the g of x function is inside of that parentheses for the f function. Okay? So every function that's going to be using a chain rule is going to feel like it's something inside of something else. And then when we're doing this rule, using this rule, you'll see that we take the derivative of the outside piece first. And again, it doesn't matter that we do it first, but that's how it's written on here. And we leave the inside unchanged. It's not any different than it was before. And then we multiply that by the derivative of the inside function. And we're going to do a whole bunch of examples so that we get a hang of doing it, okay? All right, so here's our first one. As we're taking a look at this, do you see something that looks like it's inside of something else? Yeah, I mean, the parentheses are kind of a giveaway. Not every function we do this with will have parentheses, but if you were entering it in your calculator, every function that uses this would require the insertion of parentheses, even if they weren't there already. So here we see them because we see the inside of those parentheses. All right, so what's the outside? Well, the outside is the power 5, and it's the 2 in the front. Those pieces are outside. So that's where we're actually going to begin. If you could cover up with your hand the 6 minus x squared, just pretend like it's the word stuff. I've got 2 times stuff to the 5th, okay? What would I have to do to take the derivative of something to the 5th power? All right, so I bring the 5 down to the front, so 5 times 2 would be 10. And then what would happen to my exponent of 5? It would go down by 1 and it would be a 4. All right, so what goes inside of there? Well, the same thing that was already inside. 6 minus x squared. So that's the derivative of the outside. And then we're supposed to multiply that by the derivative of the inside. So then we have to take the derivative of 6 minus x squared. So you guys are getting pretty good at this. What's the derivative of 6 minus x squared? Negative 2x. And if we were doing the gateway next week, we would leave it just like that. Okay? But we're not right now. We're doing something different. We're going to simplify it. I don't expect that you're going to multiply something to the power 4 out. That part can stay. But the 10 here at the beginning and the negative 2x at the end can certainly be combined. So this is negative 20x times 6 minus x squared to the 4th. And in a nutshell, that's the chain rule. Now, they don't all feel like that, but they all do that same property over and over and over again. Okay, the next example feels like it starts out quite different. For starters, there's no parentheses, but there really are. So you're shaking your head over there. What do you think, Nate? What are the parentheses that I would have to put if I put this in my calculator?
Well, we could put the x squared plus 3x minus 1 to the power of negative 1.
Yeah. And even if we didn't think about the negative 1 right away, if we were putting this in our calculator like it is written with division, it would force us to put those parentheses around the denominator, or else it wouldn't divide by all of it. So the parentheses really are there. They just don't show up when we write it in this form. And then I like what he said. We can actually rewrite this with an exponent. Right? We can bring all of this at the same time up to the numerator if we put a negative 1 as the exponent. And then it should feel an awful lot like the last problem. So just a couple of, observations, and we have the same picture, basically, that we had on the previous one. So what am I going to do first? We're going to bring the negative 1 down, you bet. All right, so this is g prime of x. The outside function is the negative 1 part, the exponent part. So we're going to bring that negative 1 down. And what will the new exponent be? Negative 2. What goes inside? The same thing that was there before. X squared plus 3x minus 1. And then I have to multiply it by what? All right, the derivative of the inside, which is 2x plus 3. Again, that's where we would stop on the gateway. For simplification purposes, there's really not a lot I can do. I can put the part that's to the negative exponent back into the denominator. Can do that. And the negative that's at the beginning, combined with what's at the end, can be multiplied. So if I do all of those pieces, I end up with negative 2x minus 3 on top, and x squared plus 3x minus 1 squared in the denominator. Is everybody good with that? Now, some of you might have looked at this one originally and said that we could use a quotient rule. Did anybody look at that and think that? I mean, it kind of looks like a quotient, right? And we can. We could use a quotient rule. We'll get the same answer. So when it comes down to it, in this section, the intent is for you to be practicing the chain rule. But in this one, a quotient rule actually would have found the answer as well. Quotient rule is kind of not so heavily pushed when you have a numerator that's just a constant. See how this numerator doesn't have x in it? That's actually the reason why the quotient rule is not the most natural choice on this one, because when you take the derivative of the numerator, you get 0, so you only get half of the numerator in your quotient rule processing and stuff. It doesn't make it any worse or better, it just makes it sort of not the natural processing, because it's not really a quotient of polynomials. I mean, not really, because the numerator is just a constant, so it's got this sort of funny feel to it when you try the quotient rule. It still will work, but you have to think about it carefully. All right, let's try another one. This one. This one's a lot more complicated than the two that we've done. For starters, we need to rewrite this. So how do you think we'd rewrite it? Yeah, we'll make it all to the 1/2 power. Is everybody good with that? Square roots are 1/2 power. Sorry. Yeah. Okay, so this is a funny one, and let me tell you why. There are a couple of things you could do. I'm going to do it the problem the way that it's currently written, power 1/2. So I've got this inside function raised to a power. I'm going to do the power rule to bring it down and all that kind of stuff. And then when I get to the inside of it, and I take the derivative of the inside, I'm going to use the quotient rule. There is another option. Did anyone think of something different than what I just said when you first looked at this problem? Well, we will have a chain rule on the problem, but there is a different way to do the chain rule. No, good try. Well, no, not so much. Sometimes people will distribute that negative 1/2 power. Not negative right now, it's positive at the moment, sorry. The 1/2 power. And they'll view this as the numerator to the 1/2, the denominator to the 1/2. And it works okay. If you view it that way, you end up with a quotient rule on the outside and a chain rule on the inside instead. So it just sort of changes the order up of what you're doing. You get the same answer, but it is a different way of viewing it. I like to do it with the quotient inside and the chain on the outside. That's how I like to see it. But you can do whatever feels comfortable when you encounter those problems. So if we view this as all of this stuff to the 1/2 power, what's my outside derivative going to be? 1/2 to what power? Negative 1/2, good. And what goes inside? The same thing. I know some of you are like, why does she keep saying that? I keep saying that because there's going to be like 2 of you on the test when I have a question like this who will forget that piece. And maybe if I say it often enough, it'll only be 1 of you. I don't know. We'll try. All right, so this is half of the problem, right? This is the derivative of the outside. Now I need the derivative of the inside, and the derivative of the inside, as Evan said when he first saw it, is there's a quotient here, right? Quotient rule. So we need the quotient rule, and we learned that last time. So the quotient rule does what? How does it start? The denominator, right? Denominator, so 2t plus 3. And please be careful with t's. T's are like the worst variable ever to use in a problem because some of your t's probably look like pluses. So I try to put curls on the bottom of my t's to try to distinguish them. If you really just don't want to do the t's and you switch them out for x's, I'm fine with that too. I don't care, okay? Just be careful if you use them. Okay, so here's 2t. It wasn't supposed to be plus 3. That's what you get for talking. 2t. Denominator. Oh, no, it was. Hang on. I'm getting carried away. We're ready for the derivative of the numerator. That's what we want next, right? So what's the derivative of the numerator? 6t. Good. What sign comes next with the quotient rule? It's a subtraction sign or minus sign, yeah. Now what do I need? The derivative of the denominator. What is the derivative of the denominator? 2. And the numerator, 3t squared minus 2. What goes in the denominator? 2t plus 3 squared. And this is the point when you're saying, please, please, don't make me simplify it, right? It's kind of messy, especially compared to the last two. So on the quiz next week, I won't make you simplify it. But today we are, okay? We're going to clean it up some, because that just seems like a fun thing to do. It's math. We're going to clean it up. All right, the first piece is a negative exponent, right? So in order to take something that's a negative exponent and turn it into a positive exponent, you usually move it down to the denominator, but this has a numerator and denominator, right? So what can I do to change that into a positive exponent? I can flip it. So I'm going to flip my numerator and denominator upside down. I'm going to flip the fraction, and I'm going to make it a positive 1/2 exponent. So I'm going to have 2t plus 3, and I'm actually going to, and you'll see why in a moment, write the 1/2 on each piece of it. So 2t plus 3 to the 1/2, and 3t squared minus 2 to the 1/2. Maybe we've got a massive amount of cleaning up to do on the second fraction. The denominator won't change, so I'm going to write that as 2t plus 3 to the 2 to the second power. But let's clean up what we have here, and I'm going to try to avoid having multiple steps of cleanup by doing some of it above. So this is negative 12t squared plus 18t. And over here, if I distribute a negative 2, I've got negative 6t squared and positive 4. Did I get that right? For the 6t squared? It shouldn't be. How about that? Is that better? Okay, thank you. All right, so t squareds. How many t squareds do I have? 6 of them, I think. Now that I got the sign fixed, right? And then I have 18t, and I have plus 4. It already looks a lot better, doesn't it? It really does. We're going to do 2 more things to simplify this. The first thing is to notice that this 1/2 and this piece right here can be combined. They can be simplified. The 2 in the denominator can be simplified with each of the terms in the numerator because they're all even. So I can clean that up. That's something I'll be able to do. I'll do that first. I'll just write that at the beginning. So that gives me 3t squared plus 9t plus 2. The next thing that I'm going to notice is that let me use this color. This and this match. It's the same thing inside the parentheses, right? So we should be able to combine those. So basically have a power of 1/2 in the numerator and have a power of 2 in the denominator. So what am I going to do? We're going to subtract the exponents because one's in the numerator and the other's in the denominator. If I subtracted 1/2 minus 2, what would I get? Negative 1.5 or negative 3 over 2, right? Negative 3/2. But that's negative. So I'm going to put it in the denominator so that it's not going to be negative. And if you look back at the problem, that makes sense. There's 2 of them in the denominator. There's only 1/2 of them in the numerator. So if I'm going to have this subtraction and this remainder, it's going to still be in the denominator because there's more of them there already. So what's already here was 3t squared minus 2 to the 1/2. what I'm going to include now is the 2t plus 3, but it will be to the 3/2. And then I am finished. We could go ahead and talk through again why this isn't going to factor in the numerator. It doesn't cleanly look like it for sure wouldn't necessarily, but there's no way to get a 9 in the middle with a 3 and a 2 on the outside. So we kind of get stuck right there automatically. Any questions on this one? There's a lot going on in this one. There really is. Okay, let's try something a little easier. Now, the thing about this one is it doesn't look like there's any parentheses. Any idea where the parentheses really are? What was that, Anderson?
Sine pi.
Yeah, and they're actually around the pi and the x. And so it's not good notation that they weren't there already, but that is what the problem intended you to understand it to be. That's where it should be, okay? So we do have an inside, we do have an outside. I bring this one up right now because I don't want you to think that outside functions are always exponents. They're not. The outside function here is what? Sine. And that's what it is. The outside function is sine. So on this one, it's not necessarily a difficult problem. It just looks different than the ones we've done. What is the derivative of sine? Cosine. And what will I write as the angle inside of cosine? Pi x. And then I need to multiply by the derivative of pi x. Pi. All right, pi is a number, just is also a Greek letter. All right, so we have, if we clean this up, all we have to do is move the pi to the beginning, and we have pi cosine pi x. That one was easier than the last one, right? Yeah. All right, so somebody asked or suggested this as a possibility earlier, and we're actually going to have it now. Oh, yes, please.
So technically, isn't there like a 1 up top when you bring it to the front, when you have to subtract 1 to make it a 0? Zero power. Like, why don't we do that?
Because this is the derivative of sine is cosine. We're not taking any powers. There's no powers here to deal with at all. We're taking the derivative of sine in this problem. It's really easy to get in the mindset that chain rules have to do with exponents, and they really don't. It's just that a lot of them have exponents to be involved in them. We're going to have 2 more problems here that involve non-exponent situations, so I think it'll start to make more sense when I try the next couple, okay? I do have exponents in the next 2, but they're treating things differently between them. All right, so anytime that you have a trig function that is to a power, the convention is to put the power after the trig function, right? So it says cosine squared of the angle. You guys remember that? And that's great. That helps clear up what's actually being squared. It's the cosine, not the angle, right? I mean, I get that in the problem. But it's not very helpful in terms of thinking about it for what we're doing. So the first thing we're going to do is we're going to rewrite this. And it's going to look like cosine of 3t. And I'm going to put the 3t in the parentheses. And all of that is raised to the power of 2. And say what you said out loud a little louder for me, Caleb. What did you see here? There is a chain rule inside of a chain rule here. Right? We've got the 3t that's inside of the cosine that's inside of the squared. So we're going to be doing the chain rule twice on this problem. Okay, the most outside function is the squaring now. The 2 at the beginning, or the 5 at the beginning as well, but it's the squaring on the outside that's causing us to have an outside function first. So what do I do when I have a power of 2? Don't be shy. Somebody tell me so we can keep going. You're going to bring the 2 down. So we got 10. 2 times 5 is 10. And then I rewrite the cosine 3t. And what will its exponent now be? 1, right? I brought the 2 down, now I have an exponent of 1. You don't have to write the 1. I just want to make sure you are aware that there really is 1 there. Okay? What do I do next? Well, the next thing I do is I move inside of the squaring. And I've got another chain rule where it deals with cosine. So what is the derivative of cosine? Negative sine of the same angle, 3t. And now I'm ready to go inside one more time to the 3t. And what is the derivative of 3t? 3. And we could stop there for the gateway, right? We should stop there for the gateway. We're going to clean it up some. We see this 10, we see this negative, and we see this 3. And we're going to multiply all those together. And what are we going to get? Negative 30. Everything else, this is a power of 1 right up here. So it's essentially we can treat it as though it's not there, right? It doesn't really raise it to anything besides what you already see. So then we have the cosine value, we have the sine value without the negative because we already took care of that. So then this is cosine 3t, sine 3t. Or you could write them in the other order. Any questions on that one? A little different. What notationally is different about this one than the last one? What do you guys think? There's a squared in there, right? But what is being squared in this problem? Yeah, the pi x, right? The angle is being squared here, not the cosine. How do I know? Yeah, it's not by the cosine part, right? If the cosine were being squared, it would be occurring between the cosine and the angle, because that's the normal convention of doing that. That's how we're supposed to write it. So when we see this like this, what we really have is the angle here being squared. I'm going to treat the squared just like it is as a squared, so we're having a chain inside of a chain again. But I do want you to recognize you could distribute that. You could write this as pi squared x squared. Agreed? You could do that. But just because we're practicing the chain rule, I'm going to go ahead and leave it for now so that you can see how that works out. If it had said pi x plus 2, all of that squared, distributing the squared becomes messier. So let's leave it there for the moment, and we'll see what happens. All right, so the first part, that's nice. What's the derivative of 3x? 3. All right, the next thing is that there's this negative 5 in the cosine business. That's the outside of it. So what's the derivative of the outside function? Yeah, so we're going to have the cosine becoming negative sine, right? And the negative's already there, so this will be positive. The 5 stays. So this will be positive 5 sine of what was already there? Pi x quantity squared. All of that is my angle. And then I need the derivative of what happens when we have a squared here. So what do we do when we have a function squared? You bring it to the front. The 2 comes down. The pi x stays. And it would be to the power of 1. Again, you don't have to write that, but that is what is there. And then, one more time, we have the pi x part. And what's the derivative of pi x? Pi. Right. All right, we'll do just a little bit of cleanup. We have a 5 and a 2 and a pi. Oh, we've got more than that. 5 and a 2, let's just start there. 5 and the 2 become 10. We actually have pi twice. We have it here and here. So when you multiply pi times pi, you get pi squared. And you have the x at the end. And then we have the sine of pi x quantity squared. Any questions on that one? All right. We're going to shift gears just a little bit. Directions are slightly different on this one. It says to evaluate the derivative of the function, but then it says at the given point. How does that change what we're doing on this problem? Yeah, at the very end, after we've done all the work, we're going to plug in the x value actually, just the x value. Even we don't even really need them to tell us the y value to do this problem. They do that to be clear, but they don't need it on this particular problem. So we're first going to rewrite this function in a different way. How could we rewrite this function so that we're using the chain rule? Yeah, all of this is combined. So what would I do with what's in the denominator right now? Bring it up to the numerator. And if I do that, I have to bring it up with an exponent of -1. You got it. All right, fabulous. So now we're going to take the derivative of that. Okay, so I'm going to pause real quick. I'm going to let you take the derivative, and then we'll make sure that everybody is on the same track. So write down what you believe the derivative would be for 5 times the quantity x cubed minus 2 to the power -1. Go ahead and get it into a simplified form if you don't already. All right, somebody tell me what you have. What did you end up with as the final form of what this would look like? Not with the 2 plugged in, I'm not doing that yet, but before that. Okay, one correction let me say on this one. We unfortunately cannot distribute this through. Does anybody know why? That's a common mistake. Does anybody know why you can't do that? You can't distribute the 5 through the problem. Because of what? Yeah, that exponent right there. Think about order of operations like parentheses, exponents, and then multiplication, division. You have to respect the exponents. You can't multiply through them. So we can't distribute the 5 through. So somebody else give me what you think you had then without the distributing of the 5 through. What would you do? Times x squared, what? Maybe this is what you were telling me and I wasn't hearing you, right? Is that what you were saying?
Yeah.
I was hearing the 5 was times the x squared. I'm so sorry.
I distributed it afterwards.
Afterwards. Okay, let me write down what you said then. X squared minus the 2. You'd already written down that. I'm with you. Okay, keep going and then we'll write it down one more time and I'm done. What?
No, that was x cubed. On the bottom it's x cubed.
Okay, we're going to pause. We need to have just a sec. Let's go through this. Okay. We're going to bring the -1 down. That's -5, right? Okay, good. We have the what's in the inside of this that stays the same. This piece stays the same, yes? Chain rule, and it's a power of -2. Excellent. Okay, then we need to multiply by what's inside. So what's the derivative inside? Just x squared, yeah? Fabulous. 3x squared. There we go. Thank you. But no 2's. Okay. So we're actually going to get -15x squared on top, yeah? Okay, good deal. X cubed minus 2 quantity squared. I think we got it all. Is everybody good with that? Do you see where the pieces came from? If you didn't quite get that the first time, you know where they are now. Okay. What we're supposed to do, though, at the end of that process is we're supposed to evaluate this at the point -2, yeah? So this is -15 times -2 squared over -2 cubed minus 2, and all of that is squared. All right, so on the top, when I square negative 2, I get positive 4, and then negative 15 times positive 4 should be negative 60. Good. Negative 2 cubed is negative 8. Negative 8 minus 2 is negative 10, and negative 10 squared is 100. So if we simplify this, what are we going to get? Negative 6/10, which is negative 3/5. Does that look good? Okay. The last problem, let's just power through this one if we're okay. Are we good?
Better than our slope then, that problem.
It says use a graphing utility to verify your result. We talked about that last time. You know what? That would be a good place for us to start and do this just to make sure everybody's remembering how to do that. Okay, grab your calculator. Let's do that. Go ahead and enter the same equation that we started with. F of x equals 5 over x cubed minus 2. You'll need the parentheses on the x cubed minus 2, just like we've got on our screen at the moment. And then if you'll remember how you can verify it, there's actually a couple of ways. The one we did last time and the way that works pretty nicely when you're graphing it anyway, is that if you hit the second, is it trace? Second trace, you'll come up with the calc menu, like calc as in calculate. And if you go down, I think it's number 7 on the list. So go second trace, number 6, thank you, number 6 on the list, the one that says dy dx. And then just type negative 2. Negative 2. And if we did it correctly, we should be ending up with negative 0.6. No? Yes. Okay, Caleb says yes. So let me see if we've got an error in calculator maybe. Okay, hit y equals.
I mean, we should get negative 1/2. It tells us that's the y value. Oh, no,
Oh, but you didn't. Okay, hit second calc.
Yeah,
It's number 6. Did you select 6?
yeah.
Okay, type in negative.
I get negative.
Yeah,
0.6.
it's there. Yeah, this is your y value
Yeah, I
there,
was
but
right.
it's the dy dx.
I
Okay,
don't know
we're
why I
good.
did that.
That's okay. I didn't see it either. Okay, so we end up getting the negative 0.6. So this worked out. That's the checking with your calculator business. Okay.